For the last lesson in this year, all of these systems of equations we've solved with the two equations have had one solution. Okay? When we graph them, they intersected at one point. When we solved them by substitution, there were single values for x and y. And when we solved them by elimination, there were single values for x and y. So just sort of review. Let's solve this system by graphing. So 2x plus y equals -4. We need to graph this. How would you like to graph it? Table of values, intercepts, y slope intercept. Let's do the slope intercept. What do I have to do to put it in slope intercept form? Is y by itself? So what do I have to do? I have to move the 2x over by subtracting 2x. That's correct. So y equals -2x. Write the x term first, then the number. What's the y-intercept? We should know this by now. -4. What's the slope? -2, but as rise over run, we have to put it over 1. So we plot the y-intercept of -4. And from the y-intercept, the slope tells us to go down 2 and to the right 1. So it's going to look like this. Try and be as accurate as we can. It's a little piece together. The second equation, y equals x minus 1, is already in slope intercept form. What's the y-intercept? -1. What's the slope? What number is in front of x? 1, but as rise over run, we write it 1 over 1. So we plot our y-intercept of -1, and from the y-intercept, the slope tells us to go up 1 to the right 1. And then we graph that, and we can see where they intersect. They intersect there, and that's our solution. Okay? So, when we put each of these in slope intercept form, here and here, were the slopes the same? Were the slopes the same in each one? No. Okay. So we can make a conclusion that different slopes in the equations, the two equations, will always mean there'll be one solution, one point that they intersect. And that's what we've been doing the whole unit. But that's not going to happen all the time. So we're going to look at a couple of other examples. Here, we have the same equation as the first one on the last page, but we have a different one here. So remember, we solved this one. For y, we thought of the y-intercept, we went down 2 to the right 1. So that's the same y as the first one on the previous page. Now if we graph this one, and this is previous page. Right, everybody. This one's already in slope-intercept form, y equals mx plus b form. What's the y-intercept? 3. What's the slope? -2/1. So let's graph this one. Plot the y-intercept first. Use the slope to find a second point. So from the y-intercept, it tells me to go down 2 and to the right 1. Graph your line. Where do they intersect? Nowhere. Are they ever going to intersect? No, because the slopes are the same. Okay? And if the y-intercepts are different, there are two lines, two separate lines running in the same direction forever. They will never cross each other. So our conclusion here are same slopes and different y-intercepts in the two equations means that they will never cross. They're parallel, which means there will be no solution to the system because there's nowhere that they intersect each other that we can write the solution. So you see, not all systems are going to have just one solution. Sometimes they may have none, depending on the equations. There's another scenario. These two. Well, this one was the same one, or it's one of the same ones we graphed on the previous page. Y-intercept of 3, slope down 2 to the right 1, and it looked like this. This one I'm going to solve for y. Because really, you guys should get used to graphing slope-intercept form. So I need to move the 4x over by subtracting 4x. So the equation looks like 2y equals -4x plus 6. Then I divide everything by 2. And I get y is equal to -4x divided 2 is -2x. Plus 6 divided 2, you got to divide everything, is 3. Notice anything? Notice anything? It's the same equation. So if I graph this, it's going to be right on top of the other line. So think about this question. How many times does it intersect? What would you say? If it's the same line. What do you think? Once? Twice? More than twice? Do they intersect here? Do they intersect here? 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 How many times do they intersect?
Infinity.
Infinite. Infinite.
So, same slopes and y-intercepts in the two equations means there are infinite solutions because they're the same line.
So you need to remember those three situations. If they're different slopes, one, all the time. If they're same, it all depends on the y-intercepts. If they're the same slope but the y-intercepts are different, it's two separate lines that are parallel. If it's the same slope and same y-intercept, it's both lines are identical, one's on top of the other. Infinite solutions.
So let's look at a couple of graphs.
What you need to do for each of these is you need to put each one in slope-intercept form in order to compare the slopes and the y-intercepts.
So for A, x plus y equals 2, negative 2, pardon me. How do I get y by itself? Subtract x. So I get y equals negative x minus 2, which means this line has a y-intercept of negative 2 and a slope of negative 1 over 1. Now we have to take the second equation, negative 2x minus 2y equals 4, and get y by itself. So I have to add 2x, pull the x over, and I get negative 2y equals positive 2x plus 4. And then to get y by itself, I'm going to have to divide both sides by negative 2. So I get y equals, those cancel, negative 1x or negative x minus 2, which has a y-intercept of negative 2 and a slope of negative 1 over 1,
But perhaps you already recognize both lines are the same.
how many solutions if both lines are the same?
If one's right on top of the other.
Infinite.
I want you to try B, please.
Save a little space here. 4x plus 6y equals negative 10. This space 2x minus y equals negative 1. Algebra here, I'm going to pull the 4x over to the other side, so it's going to be 6y equals negative 4x minus 10 after I do that. Then I've got to divide everything by 6, which is going to give me fractions. So I'm going to have negative 4 over 6x minus 10 over 6. Neither one I can divide cleanly. So I just reduced them to negative 2 over 3x minus 5 over 3. Here, I'm going to move the 2x over, so I get negative y equals negative 2x minus 1. Careful, we haven't solved for y yet. There's still a negative attached to it, so I have to divide negative 1. Y equals positive 2x plus 1.
How many solutions would you say? One. Different slopes.
Different slopes. One solution.
Okay, let's have a look at C. Let's use my notes to write it instead of scrolling up and down.
So we have 3x plus y equals negative 1, which will take one step
To put it into slope-intercept form.
and negative 6 minus 2y equals 12, which will take a few steps.
To put into slope-intercept form.
So the first one, I pull the 3x over and it becomes y equals negative 3x minus 1. For the second one, I pull the negative 6 over, so it becomes positive 6x plus 12 on the right-hand side. Divide everything by negative 2, and I get y equals negative 3x minus 6.
Slopes are the same, which means it's either going to be infinite or no solution, but the y-intercepts are different. So one's not on top of the other, they're running parallel to each other, no solution.
Because same slopes, different y-intercepts.
Okay.
Okay, the last example.
We're given one equation in the system. We're asked to write another equation so that the system will have just one solution, no solution, or infinite solutions. What do I have to do to this first?
Yes, put it into slope-intercept form by adding 2x to both sides. What's the y-intercept of this one? 4. And slope? Yeah, 2 or 2 over 1.
So how would you write a second equation so that there's only one solution to this one and the equation you're writing? What do the slopes have to be for one solution? Same or different? Different slopes, right? So write me an equation that has a different slope. You have infinite choices.
Y equals,
Give me a different slope.
3. You can change the y-intercept, but you don't have to. As long as this is different.
As long as it's not 2.
No solution.
Slopes have to be the same, but the y-intercepts are different. So give me an equation where this is the same, but this is different.
2x plus 5, sure. And infinite solutions? Well, it's just the same equation. 2x plus 4.
Okay. Any questions?